Now, there is, we will be doing a lab, and it hasn't been done yet, but I can sort of answer the questions for you, and it started at 2, I don't know why, but we will write our hypothesis as a class, and the snail lab, by the way, so you know, I didn't give a very good start for it at all, but the snail lab is, we are, as a class, we're going to have some discoidal shell freshwater snails, and we're going to pose a question, how does the temperature of some fresh water affect the activity level of a random snail? So we will write our hypothesis as a class. What do you think? You will use the data tables in this packet to record your data. You will use the path data page with the cool room temperature and warm petri dish diagrams to trace your snail's path. That was handed out in class. Use the temperature, and it is also on Edmodo if you need it again. Use the temperature probe to determine the temperature of your cool water. Remember to wait until your temperature has leveled out as your teacher showed you. So that'd be Miss Heaves, and she showed us that in class. I'd say either PM her or private messenger on Edmodo about that, or if you weren't there, or come in to see her. I'd actually just come in to see her, but you can do either. And record this temperature in your data table. Place the petri dish over the laminated snail page and fill with warm water. Place the snail over the S in the petri dish. So you'll see an S there for snail. You'll see that when you get to the lab. Be sure to handle the snail gently. More information on the snail lab. Start your time for 5 minutes. Observe the snail for those 5 minutes and draw a line that shows the snail's path on the appropriate circle on the path data page. Again, handed out to you in class, but it is on Edmodo. Find the distance the snail traveled by measuring the line you drew to the nearest 1/10 of a centimeter. Record this distance in your data table. Repeat steps 4 to 8 with room temperature and then cool water. Then warm water, sorry. So basically just do those in steps 4 and 8 with cool, room, temperature, and then cool water. That's what we'll be doing in the snail lab. Return your snail to your teacher and then wash your hands thoroughly. Compute the class average for distance traveled by the snail. So I think maybe next slide you'll see a snail, but our snails won't be going that fast. You probably won't have a speedy snail or a sleepy snail. You'll probably just have a normal snail. And there you go. And it looks like the crowd likes that snail. Now, I thought this was funny. This is definitely not the kind of snail we will be using. This is a little bit too fast of a snail. For one, we won't have a rocket attached to his back, and 2, he won't be smoking at the foot. So, that is not an accurate representation of what we'll be doing in our experiment, but I thought it was funny, so just for laughs, I thought I'd add that in there. So, for the snail lab, what was the manipulated variable in the snail experiment? The manipulated variable in the snail lab is the temperature of the water. I shouldn't have put these on this page. I should have given you time to answer. Don't look at the screen. What is the responding variable in the snail experiment? What do you think it is? It is, the responding variable in this snail lab is the distance the snail travels. Where do freshwater snails typically live, if not in an aquarium in our classroom? So, freshwater snails generally live in lakes, ponds, rivers, and streams. Pretty obvious. What environmental water temperature do freshwater snails prefer to live in? The discoidal shell snail, which is the snail we'll be using, will prefer a temperature of around 10 degrees Celsius, which is 50 degrees Fahrenheit, and to 28 degrees Celsius, which is 82 degrees Fahrenheit. Here is a, we had a, and I thought this would be a nice way to wrap things up for this slideshow. We had a review on QuizStar. I took some screenshots of our review. So let's review this. You should wear safety goggles when heating with a hot plate, when mixing chemicals, when using sharp instruments. Not for every lab, because they didn't add glassware, but that's another thing. But I told you that would be a big question. So laboratory safety definitely does comply, and there will be a fair amount of questions that have to do with laboratory safety on the test. What is the first thing you should do if glassware breaks in the lab? Tell Miss Heaps. Pretty obvious. You don't have to call Nurse Stevenson. That'd be a false alarm. For question 3, if you see the safety symbol below, that means, ooh, Miss Heaps made a mistake there. That means, you should keep in mind all rules about electrical safety. Pretty obvious, since that is a plug. Usually scientists pose questions based on things that they observe. An example of this would be the story about Isaac Newton wondering about why things fall down and not up when an apple fell and hit him on the head. Like I said, probably gave him a brainwave. So the answer to that would be true. True. It's very true that usually scientists pose questions based on things that they observe. Question 4. Usually scientists pose questions based on things they would... Oh, I added that one twice. Okay, well, pretend number 4 is not there. Number 5 is scientists design an experiment to test their what? Conclusions, hypothesis, or observations. Scientists design an experiment to test their what? Hypothesis. So, that's answer number 5. Number 6, when scientists analyze their results and want to see their data visually, they might make a graph. That's the answer to that. That's what I was saying, when bar graphs and data, no, not data tables, bar graphs appeal and cater to visual learners. In a good controlled experiment, the only types of variables that should change are the what? Manipulated and responding variables, controlled and responding variables, controlled and manipulated variables. Which one would you pick? I'll give you 5 seconds. The answer is manipulated and responding variables. Johnny wants to know if Franny's fabulous organic fertilizer will really help his basil plants grow taller. So he puts his 2 basil plants in identical planter pots, and this kind of reminds me of the Tom Sawyer experiment, to be honest, probably because of the botanical thing, and places them next to each other on his patio. Every day for 10 days, he gives one plant 25 milliliters of Franny's fabulous organic fertilizer, as does not give any fertilizer to the second plant. He measures the height of the plant in centimeters each day. He also gives both plants 250 milliliters of water each day. At the end of the experiment, he determines which plant has grown the most. What is the manipulated variable in the experiment? That manipulated variable is whether the plants get fertilizer or water. The QuizStar Unit 1 review continued. 9. Question 9. Johnny wants to know if Franny's fabulous organic fertilizer will really help his basil plants grow taller. Again, same thing. Every day for 10 days, he gives one plant 25 milliliters of Franny's fabulous organic fertilizer and does not give any fertilizer to the second plant. He also gives both plants 250 milliliters of water each day. So there's going to be quite a few questions on Franny's fabulous organic fertilizer in this review. So just remember that at the end of the experiment, he determines which plant has grown the most. What is the responding variable in this experiment? So that's the difference in this question.